Let's take a look at some simple problems from section 5-3, and we'll be beginning on page 218 in the textbook, and we'll start with number 6. And it says in exercises 5 through 12, determine whether the given procedure results in a binomial distribution or a distribution that can be treated as binomial. For those that are not binomial, identify at least one requirement that is not satisfied. So in number 6, we have the Y-sort method of gender selection developed by Genetics and IVF Institute is designed to increase the likelihood that a baby will be a boy. When 291 couples use the Y-sort method and give birth to 291 babies, the genders of the babies are recorded. Okay, in this case we have a given number of trials, and we're recording either boy or girl, which is equivalent. One could be a success and one could be a failure, depending on whether you're more interested in counting the number of girls born or the number of boys born. So that would be binomial. Okay, moving on to number 8. In an Idaho potato commission survey of 1,000 adult subjects are asked to select their favorite vegetables, and responses of potatoes, corn, broccoli, tomatoes, or other were recorded. Okay, as we look at this, it's not binomial simply because each of the responses were given too many choices. We have 1, 2, 3, 4, 5 different choices there, so it's not binomial. In number 10, we're surveying senators, and different senators are randomly selected without replacement, and the numbers of terms that they have served are recorded. Okay, so we're selecting 10 different senators without replacement. Okay, and so how many senators? We have 100 senators, so we're selecting 10% of them. That means that we're beyond the 5% rule, so we can't use that. And since it's without replacement, each time you select a senator and remove him, the probability will change, so it's not binomial. Okay, and one more of these, online shopping. In Consumer Reports survey, 427 different women are randomly selected without replacement, and each woman is asked what she purchases online. Responses consist of whether clothing was identified. So it is binomial. Either the person selected clothing or they did not. And so certainly the sample size, we want to look at the 5% rule because this is being done without replacement. So because of that, if we think about all the women in the world, the population of all women, 427 would be less than 5%. So because of that, we can treat it as binomial. Okay, 16. We're using the binomial probability table. That's table 1 in the A1 in the back of the book. And we'll do number 16. It says find the probability that the number x of correct answers is at least 3, and we're using n is equal to 5. That's up in the paragraph before, and p is equal to 0.2. So n equals 5 and p equals 0.20, and we're to find the probability of at least 3. So that means we're looking at the probability of 3 plus the probability of 4 plus the probability of 5. Okay, since n is 5, at least 3 would indicate 3, 4, or 5. So let's go to our table. And I may have run off the screen a little bit there. Sorry about that. Let's go to the table in the book and look at that. This is our binomial probability table. Let me see if I can move my window over a little bit. Sometimes it's hard to hit it right in the center. Okay. More or less, I think I've got it centered. Alright, so we're looking at, in this case, notice we have a couple of columns. N is in the first column, then X, that's the number of successes, number of trials, and then we have our different probabilities P across the top. So we're told we want to work on n equal to 5, so it's this group right here. And we want to work, I've got to scroll back up here, for our probability to be 20. And let me see if I can, don't think I can get the pen to write on this, so we'll just have to. So when we look at 20, it's 1, 2, 3, it's the fourth column over. 1, 2, 3, 4. So we're looking at this group right here. And we need to add up the probabilities, we said, for 3, 4, and 5. So the probabilities for 3 successes, 4 successes, and 5 successes. We have, for 3 it's 0.051, for 4 it's 0.006, and for 5 it's essentially 0. So 0.051 plus, and I always have trouble remembering, 0.051 plus 0.006 and then 0. Okay, so we're going to get 0.057 as our probability. So as you can see, it's pretty easy to do the table. 18, find the probability that the number x of correct answers is fewer than 12. Okay, so we're still using the same thing as we did in 16. X is fewer than 3, so that would be the probability of 0 plus the probability of 1 plus the probability of 2. I'm looking at all the ones that are less than 3. Okay, so let's go to our table. Okay, 0 is 0.328. I'm just going to jot these down to 0.328, 0.410, and 0.205. So I'm going to take those back here. 0.328 plus 0.410 plus 0.205. And I want to add those up. Clear 0.328 plus 0.41 plus 0.205, 0.943. Okay, so as you can see, the table is fairly easy to use. The problem is with the table, we don't have all values of n. It actually only goes up n equal to, I believe, 15. And also the probabilities here across the top, we don't have every possible probability. So that's what makes the table difficult in some cases. Now, in the next group, we're looking at blood donors. Around 45% of them have blood that is group O. Okay, so probability of group O blood is 0.45. So in 22 we're told N is we have 16 individuals, blood donors, and we're looking for X equal to 6. So we're to use the formula, and I'm going to put the formula up here, was combinations of N objects taken X at a time, P to the X, Q to the N minus X. So our N is 16, our X is 6, and our probability, this is going to be our P. I'm just going to do, that means Q is 0.55. So probability of 6 successes is combinations of the 16 taken 6 at a time times 0.45 raised to the 6 times 0.55 raised to the 16 minus 6, which would be 10. So what I'm going to do is use the calculator for this to simplify it. Jotting it down so I won't have to go back and forth. Okay, so let's go to the calculator. And I'm going to need to move my window back over here so we can see the calculator. Clear it. Go. Okay, so I need combinations of 16. Okay, math, I want to go to combinations, which is number 3. Taking 6 at a time. And I'm going to go ahead and get that number, and I want to multiply it times 0.45 raised to the 6th times 0.55 raised to the 10th. Okay, and I'm coming up with 0.1684. I would round that to 0.168. Okay, in 24 we're doing the same thing. This time N is 11, and we're looking for X equals 9. N is 11, X equals 9, otherwise it's the same probability, so it's combinations of the 11 taken 9 at a time, 0.45 raised to the 9th, 0.55 raised to the 11 minus 9 would be 2. So again, I'm going to do this with the calculator. So let's go to the calculator. And I want 11, math. Combinations is number 3, 9. Okay, and I want to multiply that 55 times 0.45 raised to the 9th times 0.55 raised to the 2nd, 11 minus 9. And I get 0.01258, so 0.0126. Okay, the book is getting 0.0125. I'm getting, when I round it correctly, I'm getting 0.0126. So I'll dispute them